Hello everyone, my name is Anmol Kumar. My registration number is URK23CS1013. This is my experiment number 2 from the MLT lab, and this is about feature selection and PCA. Here I implemented the feature selection using techniques like correlation filtering and recursive feature elimination from sklearn library. I also applied PCA using sklearn's PCA module. What is PCA actually is? It is uh, it is about principal component analysis and unsupervised machine learning technique, which is used for dimensionality reduction by transforming high dimensional data into fewer uncorrelated dimensions called principal components while preserving maximum variance. So that's the basic idea about the PCA, and we can use this using the sklearns module and PCA module to reduce dimensionality. As I've said, the code compares the model performance before and after the feature reduction to show its impact. So we'll see it in the coding as we have different kinds of tasks available since we are using Jupyter notebook. In this, we have first imported all the specific requirements libraries like NumPy, Pandas, Matplot library, and Seaborn. So since we have got a confirmation message that all libraries have been imported successfully, then we go and load the data set. Here we have been given a data set for our project or the experiment is the wine data set. So here we go with the feature names, which is wine data dot feature names, and then the target names where we are targeting a specific value, which we'll be implementing the feature on. Hence, this is a basic idea of what is available in the CSV data and what are we targeting. Since we are training the model for the feature, we are implementing train test split model here. So using the sklearn model selection, we will implement a model called train test split. Here we're going to train we're going to be training X train, testing the X, then we'll be training the Y and testing the Y again. So this is how the train test split is done, dividing into in two parts, X and Y, and test size would be zero point 0.3, random set will be 42, and stratify is equal to y. Since now PCA deals with the variance, so we also need to provide a variance threshold. So using the sklearn module library again, we will import a variance threshold. We'll provide the variance threshold as zero point 0.5. Since what is variance threshold here is basically removes the features whose variance falls below the set threshold. So any value below the zero point 0.5 appearing on in the threshold, it will be dropped and it won't be considered for the model training or for the fit or any transformation. So here we are implementing it like that, and since we are using correlations also as variance is existing in this experiment, we will also consider a heat map for a better visualization for our data. So this is a basic visualization. Then we are using an RFE. Again, we'll use a sklearn model feature selection. We'll implement random forest classifier also because we are classifying the data into uh, one part and the another part. This is the RFE feature selection using the basic plotting. Like alcohol is green, malic acid is red, and flavonoids is green. According to these values, we can also save the image also as available to our availability or requirement. Since random forest feature importance is there because like estimators we need 100. So 100 times it will estimate and go up to the random state of 42. And we'll find out that whether it fits the training model or not. Like X train and Y train, we split it into two parts, whether it fits into those two parts or not. Since if it fits in that part, we'll directly plot it using the bar graph. And according to bar graphs, we'll be getting following values, these correlation values, variance values, depending on the requirement. Then we'll perform the standard scaling, and then the PCA full components will be printed, and as we have already trained the model, we'll get the cumulative and the PCA values for each of the given required task. This is the PCA visualization, the final one, where the training of the model has been done. It has been separated. It has been maintained, and now the visualization for this has been done. Scree plot. This is where the values are being compared for the basic plotting of the of the graph after the PC has been implemented. Then PC1 and PC2. This is the one data where like PC1 as in the feature number one with the one model trained under X, and the PC2 is the model trained under the Y. So this is how the training of the model is done and the visualization is being done. We can reduce the PCA also, like if you want to clean the data more. So continuing with it, we will have the evaluation function also. The criteria should meet the evaluation. And last but not the least, we'll print all the results in an array, and then we'll convert it to data frames using the pandas library as usual. And here are the results printed. Final comparison plot can be done using the bar chart and the scatter plot. Feature versus time, the accuracy comparison, PCA1, PC 95%, RFP, variance threshold, all these values can be matched. So any value below the 0.5 has been dropped, or it's not been considered, or it directly goes up to the 1.0. That is why the bar chart is this much high. Thank you.